Hi, this is Mrs. Richart here, and today we're going to give you some examples of multiple transformations of f of x. This is going to help prepare you for the practice assignment today as well as for your quiz tomorrow. So here we go. This is our original function, and we can transform any function, but for this function, we're going to look at those 4 points that are given. Here's our table of the 4 points that are given. -6, -5, -2, 2, 0, -4, and 6, 2. Here's our first transformation, 2 f of x minus 1. These are both on the outside, so they're an outside change and it affects the y. Here's our original table again. So if we want to transform this to our new table, the x's stay the same, so I'm just copying those down. Because the change is on the outside and it affects the y value, we say 2y minus 1. 2 times the y value is minus 1. 2 times -5 minus 1 is -11. 2 times 2 minus 1 is 3. 2 times -4 minus 1 is -9. And lastly, 2 times 2 minus 1 is 3. So this is a vertical stretch by 2 and a shift down 1. And here's what the graph looks like. So if you notice, the graph has been shifted down and vertically stretched. If we take a look at another transformation, we have f of x minus 4 plus 2. Notice that this x minus 4 is inside and it affects the x values. And so we do the opposite. Inside is opposite. This plus 2 is on the outside, and so it affects the y values. Here's our original table again. And now here is where we're going to do our transformations. For the x value, we're doing the opposite, so it's x plus 4. And for the y value, it's the same. So for our x values, we add 4 to -6 to get -2. Add 4 to -2 to get 2. Add 4 to 0 to get 4. And 6 plus 4 is 10. For the y values, our coordinate rule is y plus 2. So notice the x is the opposite, the y is the same, y plus 2. So -5 plus 2 is -3. 2 plus 2 is 4. -4 plus 2 is -2. And 2 plus 2 is 4. This is a shift right 4 units and a shift up 2 units. Inside's opposite, outside's the same. And here's the graph. Notice how our graph is the same size and shape. It's just shifted right and up. Right and up. And if you go from one point to the next, we see it's shifted right 4. So if we take here, 1, 2, 3, 4, and up 2, 1, 2. And that'll be true for every point on this graph, from the red to the blue. For our last example, we have -1/2 f of 3x. This 3x is on the inside, and inside is opposite, and it affects the x value. So it looks like we're multiplying by 3, but we're really going to be dividing by 3. This -1/2 is on the outside, and it's going to change our y values. Here's our original table again from the first function. For the x values, we're going to do the opposite. It looks like it is 3 times x, but we're actually going to be doing the opposite, divide by 3. Dividing by 3 and multiplying by 1/3 are the same. It looks like it's a horizontal stretch, but it's actually a horizontal compression by 3. -6 divided by 3 is -2. -2 divided by 3 is -2/3. 0 times 1/3 is 0, and 6 times 1/3 is 2. For the y's, it's the exact same. So it's -1/2 times y. Well, the negative is going to change the sign of every y value. So we have negative times -5, which is a positive 5, divided by 2 is 5/2, or 2.5. 2 times -1/2 is -1. -4 times -1/2 is 2. 2 times -1/2 is -1. So we see that we have 3 transformations going on. Reflection over the x-axis, that's the negative. A vertical compression by 2, that's the 1/2. and a horizontal compression by 3. It looks like it should be a stretch, but it's actually a horizontal compression because it's inside. Lastly, here is our graph. We have a reflection, and we have a vertical and horizontal compression. That's why it looks like it's been reflected over the x-axis, and it's smaller in both directions. So now I encourage you to complete your CAMI practice and make sure you check the key before you submit it. And lastly, then you will prepare for tomorrow's quiz. Hope you have a great day.